All right, let's continue. This second part, we're looking at different types of cells again, but this time we're looking at concentration cells. First, we looked at galvanic or voltaic cells. So let's look at concentration cells. We look at introduction, examples of concentration cells. We'll explain concentration cells, then illustration, and we'll conclude. A concentration cell is an electrolytic cell that is comprised of two half cells with the same electrodes but differing in concentration. So just like the name goes, the difference is the concentration. For example, if you're looking at the Daniel cell, instead of having zinc and copper electrode, we now have the two electrodes being the same zinc electrode. And the only difference will now be the concentration of the electrolytes. That's why we call that concentration cells. A concentration cell acts to dilute the more concentrated solution and concentrate the more dilute solution, creating a voltage as the cell reaches an equilibrium. So there will be a flow, to equilibrate the high concentration and the low concentration until the two concentrations become equal. So the high concentration will be dropping and the low concentration will be increasing until they strike at the equilibrium point. This is achieved by transferring the electrons from the cell with the lower concentration to the cell with the higher concentration. With the expiry of time, the two concentrations tend to become equal. Thus, at the start, the EMF of the cell is maximum and it gradually falls to zero. There are basically two types of concentration cells: electrode concentration cell and electrolyte concentration cells. Now, this is an example of the concentration cell. Look at the electrode here is nickel. The electrode here is still nickel. So we'll have the same electrode for the oxidizing half cell and reducing half cell. Now, but look at nickel ion concentration here is 1.0 times 10 to the power minus 3, whereas here is 1.0. So the difference in these concentrations will now make this cell a concentration cell. Our salt bridge, of course, is there, and the electron flows from the left hand here to the right hand electrode. This is an example of a concentration cell. Yet another example of concentration cell, still have our salt bridge. This is copper electrode. This is copper electrode, 0.1 mole copper and 1.1 mole copper. This is our oxidation anode and this is reduction cathode. The electron flows through here. So when it is at equilibrium, you have 0.00 volts. No electron is flowing from any side. So that's another example of concentration cell. So these cells, by virtue of simple change in concentration of the species, we call them concentration cell. For example, look at the C1, C2. The same species that is on the left, hydrogen and hydrogen chloride, hydrogen and hydrogen chloride, platinum electrode, platinum electrode. The difference is C1 and C2. The reaction at the left hand electrode is this. Look at it, oxidation. And at the right hand electrode, we have reduction. The overall process is given as this. The net process shows that this is simply the transfer of hydrogen ions from solution of concentration C2 to concentration C1. If C2 is greater than C1, the process will occur in the direction indicated and it will have positive EMF. But if C2 is less than C1, then it means the process will be reversed with a negative EMF. Therefore, for the concentrations C1 and C2, let's apply Gibbs energy. G1 is this, Z2 And then delta G is equal to RT ln C1 over C2. That's basically what was made before. Then we can now put, in terms of our number of electron transferred, Faraday and E cell for the reaction, and we arrive at this. And automatically that gives us this for E cell. An illustration, calculate the cell EMF for the reaction. This is the reaction. Concentration is 1 molar here. Concentration here is 0.1 mole. Look at it. We have the E naught values for the two cells. So we're now applying E right minus E left, which gives us this. And we apply that equation, log of concentration, C2 and C1, and we get our answer. There we come to the conclusion of this module. And of course, if there's any problem, you're free to throw in your questions and we'll make more explanations. Thank you very much.